I'm going to be diving into application security that's being brought to the market by AppDynamics, and this is Cisco Secure Application. It is in partnership with the security business group within Cisco, as well as partnership with folks like Tim and our incubation group, to make sure that we're giving visibility in the runtime environment to both the app teams as well as the security teams. And I want to say something here that you might say is pretty obvious, but the importance of digital transformation, especially now, is unbelievable. It's how the world is starting to always lead with every single experience is always going to be a digital first experience. In the last 2 years, we've seen a 30% increase, obviously driven by the pandemic and everyone having to work from home and get more in touch with their family and their home environment. And what that's done is create some new expectations around the businesses that are doing digital transformation. 96% of businesses actually fear significant negative consequences if they don't deliver an amazing experience for their customers. And then if you look at the customer perspective, 70% of customers actually said it's rude when the digital experience is bad. Like when you go to order your pizza and the app doesn't work right, they consider that to be a rude experience, which is a really wild transition that we've seen. And this is what I love, because I live, in addition to both on the application performance management side, I live in the AppSec side of things. This perspective is really fascinating. You have to deliver an amazing digital experience. Why aren't you securing it? 47% of security professionals have nothing to secure their cloud apps. And when a breach does happen in those unsecured applications, 60% of breaches, the data is gone within 24 hours. So you have a really small window of time to find it. You don't have all the tools there to see it. And then when things start getting hairy, most security professionals, sorry, not most, 35% of security professionals actually ignore alerts when their queue gets full. And that's just, that's physics. Like you can't do everything. So how do you make sure that you've got the right tools in place that give you the immediate knowledge when something's happened, and make sure that you're prioritizing it based on what matters to the business, right? Your business is now a digital business. How do you make sure that you're focused on that? And then it gets even more interesting due to the silos that end up existing between the app teams and the security teams. I won't say there's animosity there, but there's definitely frustration. And I'm going to guess that you guys, having lived in the IT space for a long time, have experienced that yourselves, where the app teams are like, hey, I've got to push stuff out fast. I don't have time to wait. I got to make sure that my user experience is perfect. I don't want to worry about having to get security compliance. I just got to go. Security teams that's great and all, but I have to maintain the risk posture of our company. Otherwise, we have significant financial impact, brand impact, and I could lose my job. So there's these teams that are constantly going back and forth. Have you guys had any war stories from being in the IT space where you've had to butt heads on either side of the fence?
No, because it's always the network's fault, right? It's never us. Application developers never cut corners.
Yeah, it's a constant battle between dev and operations.
Yeah. The stories that I end up hearing are like, hey, we had to poke a bunch of holes in the network or in the firewall. We had to submit a bunch of cases. It took months to do. We decided to cut all around it. We opened up one port, did a service mesh, and piped all our traffic through the service mesh. Security has no clue what we're doing. Those type of hacks might get the app team moving fast, but you lose that visibility, and then you're putting your whole business at risk. And we can't really afford it. And I hate to kick a horse that's down, but Log4j is a really good example just from that scenario of it is so serious, the whole business has to stop and react to it. And everyone at that moment in time now becomes a member of the security team. Everyone, I can say within AppD and all the customers I've spoken to, my holiday was ruined. I was at work and I was making sure that our infrastructure was completely secure and protected, and that our customers were secure and protected in their environments. And every customer I talked to had that same experience. And who were the players? It wasn't just the security team. It was security and app working together. But they had a big gap to cover because they weren't using the same tools. They weren't using the same terminology. And so there was a lot of friction and a lot of time spent just saying, hey, where is the problem? hey, how do we even fix the problem? And if you just look at this, I love this chart from the Swiss government that mapped out all the different places which you can put in protections or controls, mitigations, remediation. It's really like there's no one team that could do all of that. It has to be together. So like tearing down those bridges to come together is essential. So anyone here lose any of their holiday or break to Log4j? Or is it just me who suffered? Ben? No, it wasn't fun, but it was a great learning lesson. And I think what we came out of it was a lot of folks that are a lot stronger, and they start adopting a lot of important processes that they can take to make sure that the next time it happens, they're protected. And this is where I want to pivot into our view on inside-out security. A lot of the times we talk about security products that sit outside of the application. Why is that? It's really easy to put something that's at the perimeter or something that sits outside of the code. The moment you mess with code, app teams get super defensive for good reason, because it could jeopardize the user experience or it slows down their ability to push out their code. So because of that wall between app and security, you end up having controls, including like security testing, like a DAST solution, or you've got your WAF or your firewalls that all sit kind of outside of the actual code itself. But we believe that if you want to be able to move with the application, understand the application, that you not only need all of those other tools outside of it, you need to also have some visibility to what's going on inside the code itself. And that's where Cisco Secure Application comes in. This is a view of the architecture for AppDynamics that is an agent-based architecture. Actually, another question for the group. So I'll do a little bit of one-on-one on AppD, and I'll try to sprinkle that throughout so you can start connect some of the dots. So first and foremost, AppDynamics is about understanding how the application is behaving and how users are using that application, and then mapping that all back into business insights. So you can start measuring, for instance, hey, we see a slowdown in a particular API endpoint. That slowdown is being seen in this particular region. It is having this type of impact on your revenue, on the transactions that are traversing your cart checkout service. And these are a list of users that had problems. We'll alert you to that and then help give you call graphs or actual lines of code that could have been introducing that fault. So we have like extremely deep insight into not only the code of the applications, how the application is performing, how they're chained together, how users are using them, but also how it impacts the business. And we said to ourselves, if we have all these agents that are out there on the end user side in like IoT devices, mobile devices, in the browser, we have agents that are sitting on servers next to the database and inside the code itself, right? Whether it's Java, .NET, Python, Go, Ruby, on and on and on. We have all this visibility. What can we do with that data? You can do a lot from a security perspective. It's actually a treasure trove of information that typically security folks don't have any purview to. So what we did was layer inside of our application performance management agent, that APM agent, we added security capabilities. So we can get some visibility and some control that actually sit inside the code and can see functions being called, parameters being passed around. And then we send that all back up to the same AppDynamics cloud where we're receiving all their other telemetry and kind of mix it together to create this beautiful stew that we then are able to extract out where the problems are and bubble those up in alerts and notifications to both the app teams and the security teams. And there's 3 use cases we wanted to solve. The very first one is having common language to talk about things. It's really often that, for instance, the security team would come forward and say, hey, we saw an incident on this IP address. And the app team would say, IP addresses are meaningless to me. I work in Kubernetes. They're overlapping subnets. They're kind of throwaway. Give me some information. What service are you talking about? What's the application that you're talking about? Give me a name or some kind of metadata. So we start merging all of our security insights back to the same terminology that the IT ops organization is using to monitor the health of their applications, so they can have a seamless dialogue back and forth. That also allows you to prioritize which application is most important. Is it a back-end service that's used for processing non-customer data, or is it something that's handling your transactions where you're interacting with your end user and taking in maybe their PII data, credit card information, et cetera. So once we have that connective tissue between security and the application side, we then said, all right, we're inside the code. What can we see there? We can see the libraries that are being used. So what is the software composition that is creating the application? As you guys might know, I would say 50 to 75% of all applications are actually not even custom code. It's going to be libraries and third-party APIs that are delivering a lot of these capabilities. So it's really important to understand what are those things. So we'll look at the software composition analysis. We'll say these are all the libraries you're using. And then we consume two different vulnerability feeds to then correlate where are the vulnerabilities in those libraries. Then we also look at runtime behavior. What functions are being called in the app? How are parameters being handled to those functions? Does that appear to be a vulnerable behavior? And then we will provide remediation guidance. Here's what you should do to fix that. All right, so that security teams can go to the app teams and say, hey, by the way, we found this really bad vulnerability. Here's how you go and fix it. And if possible, we'll actually patch it. So no code has to be touched. We can inject HTTP security headers, as an example, into the responses coming back from a service so that you don't have to go back to the app team. And then finally, we do attack detection and protection. So if we see something that we believe is malicious occurring inside the application, we can bubble that up and let them know that something's going on that's abnormal. We also have the ability to enforce a policy that can be controlled by the security team or the app team, but most likely it would be a SecOps group. They go in to find policy that then is enforced in that application. And I'm going to give you an example of how all this stuff actually makes sense. I want to make this kind of real for you. So let's talk a little bit about what all these different common components that exist in the runtime security stack are going to see along the path of an attack. And what we are with secure application is a RASP. We're more than a RASP. We're kind of like a RASP, but SCA and IASP, but let's just call it a RASP for simple terms. So we've got this attacker. Their goal is to leave a backdoor within your compute on your workload somewhere, right? Whether that's an EC2 instance in the cloud or your private data center, it doesn't matter. There's some compute. They're going to send the request in. The first layer there is going to be your perimeter with your firewall. They're going to see something like, hey, this looks like it's coming from an odd geo. You don't normally see traffic from that geo. We're going to call that out. You have a chance to block it there. In most cases, you're not going to do something if it's just coming from an odd geo. Then you're going to have your load balancer that's going to decrypt it and then pass it off into your environment. Then you have your WAF, right? Your WAF, your web application firewall, is going to look for user input to say, hey, I'm seeing something odd here. In this particular case, they might say, I see serialized data. Serialized data is just a way to encode data that you pass between applications. So they'll see that serialized data, they think, based on a signature, and they'll say, this might be malicious, but I'm not 100% sure. Then it passes off to your cloud workload protection. This is someone that's sitting in the compute side. And they're going to say, I see a connection that's entering in, hitting a process, and then I'm seeing that process that just got hit with a connection spin up a whole new process, right? So they'll see that spawn something else. But they're not sure exactly the intent of that because they can't see into the layer 7. And then you've got the RASP. And the RASP will actually see that the business logic was taken advantage of to deserialize an object that was passed in through a request. And then that deserialization then triggered a process to be spawned or remote code execution. Now, each one of these layers is a signal of risk. And each one of them, you have to make a decision as an organization, where do you want to go ahead and block that request? Depending on how much risk you're willing to accept, you might let it get all the way through to the application, or you might stop it earlier. But this kind of lays here's some of the differences in what they see and they do at these different layers. So I want to apply this to Log4j because it's top of mind. People have been thinking about it and understand a little bit around the attack. I'm going to explain briefly how it works and then explain how a RASP is able to, and specifically Cisco Secure Application, goes about blocking it. So first off, a bad actor would send in a bit of data. That bit of data would be logged by the Log4j library. In the Log4j library, it actually supports something called a context lookup, where you can take this data, this JNDI, and it says do a lookup via JNDI to HTTP://bad actor, right? That request actually triggers a call out to let's say a malicious LDAP server. And that malicious LDAP server then redirects that application, the Log4j library specifically, back out to another malicious server that actually delivers a malicious class. A class is just a function, and it's a code to be executed. And the Log4j library then takes that code, happily executes. Now, why would this happen in the first place? Log4j allowed for you to manipulate data based on code that could sit in some other server to maybe dress it up a little bit, add some additional context. In this case, attackers are like, well, I can actually get it to execute any code I want. I can take and alter the way the transactions are occurring. I can steal data. I can modify data. They basically own that application and the underlying workload entirely.
I don't know the proper term, but I have a question on, I think it's called secure compute environment, where the process is running in a secured off area of the processor, and the memory that it's running in is a separate part of RAM in the machine, and it's possibly encrypted. Does that hinder AppDynamic capabilities at all, or are you able to work around those type of environments, or it's not related at all?
Yeah, so we run in the same context as the application. So as you spin, like in the case of Java, you have a JVM, right? That's the runtime environment for a Java app. And we run inside of that JVM at the same privilege as the application itself. However it's being run, whatever the compute is, we will happily run alongside it. So for secure application, when it's in this environment and this attacker sends in this bad data, well, the very first thing, even before they send it in, actually, this is what happened to us internally because we're running a Cisco secure application in our production environment. The moment that vulnerability was released publicly and put into all the vulnerability feeds, we knew about it. And because we knew exactly what was running in production environments across our entire footprint, we could say, hey, log4j, vulnerable versions exist here, 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 and here, and here. We didn't have to go and hunt for it. We knew exactly where it was. So that's a really important thing to do, because even if you try to shift left and fix it in your code, which you absolutely should, we've had multiple examples where dev teams have said, we fixed it, it's done in the pipeline, and we're good, not realizing that not all of the actual instances that are running in production had been taken down. They had fixed it, but there was still some old versions that were out there running. We were able to give visibility to that. And so that's the first thing. It's just that instant visibility. Does the vuln exist in my environment? Then the next piece is if someone were to try to take advantage of it and exploit that vulnerability, so this bad actor sends in the payload to go do that lookup to the malicious LDAP server, we can define a policy that actually blocks the use of that vulnerable library from reaching out to the network to even start that attack chain. So it dies right at the very first time it tries to work, and we will notify that attempt occurred. And I'm going to actually give you a demo of the platform, and we'll kind of show that. So in this case, we both tell you where the vulnerability exists so you can remove it, how to remediate it, and then also stop it from occurring. This is the AppDynamics administrative interface, or the controller UI. And I'm going to take you and walk you through the lay of the land, since you guys aren't AppD users. This is what we call the flow map, the application flow map. And we have 3 different levels of hierarchy. We have an application, a tier, and a node. An application is a collection of microservices, which we classify as tiers. So these circles here are a tier. And within a tier, you can have multiple nodes. In this case, we've got just one node in each one of these tiers, or one instance of a microservice. And then if you go out here, we can see a connection from the commerce service going out to the AD financial application, where we've got 18 tiers and 57 nodes. So this is out of the box. This is nothing to do with what the Cisco secure application capabilities are. This is just AppD's APM solution that maps out the interdependencies between all of the components of an application. And what's really neat about this is it's not just microservices. We have visibility into things like your databases, MySQL, Postgres, etc., into your message queues, into external APIs. You can see your call out here to FedEx. And we have visibility across multiple languages: Java, PHP, .NET, Python, C++, etc. So this is an amazing amount of view that most security folks don't have at their fingertips, and certainly not categorized and broken down in the way that app teams look at it. So this in itself is valuable to security folks. But what we've done is taken in our visibility to the health of all these services and the transactions that are going across the application. We also start bubbling up the security events here. So in the same dashboard, they can see that they've got critical issues and warnings that they need to go deal with as it pertains to this particular application. So if they go ahead and follow through on security events, they'll land into the security dashboard here. And first thing they're going to see is the overall health of the AD retail application. They'll see how many vulnerabilities are there that are open, how long they've been open, how things are trending. And obviously you'd want them to be trending down, that you're fixing your vulnerabilities quicker than you're actually creating them. You can also get a purview as to what type of attack activity that you're seeing occur in your environment, any type of just general observations of application event behavior. And then I want to pivot into the applications view, because the very first thing anyone's going to do is say, hey, I don't want to deploy a new agent. I don't want to insert anything else into my environment. It's a real pain. That's the beauty of leveraging a single agent to do both APM and security. If someone's an AppDynamics customer, to leverage a security capability just means you have to be on the right version of the agent, and then you have to just turn it on. Once you've turned it on, you instantly start getting insights. And here you can track how all of the nodes are actually coming online, and if they're enabled, are they registering, and are they secured? Once you have your environment all ready to go and secured, then you start getting a ton of information. So within about 5 minutes of activating this, you will get complete view of all the libraries used in all of your applications, all the vulnerabilities that exist in them, as well as what kind of observations you're seeing from these applications, what network access, what file access, any kind of vulnerable behavior. All of this information out of the gate, 5 minutes, without any config, any work, right? So huge time to value, great visibility. In the case of Log4j, for instance, you just have to turn it on and then we'd be able to tell you you've got Log4j vulnerable instances in your environment that you need to take care of. Let's dive into some of the library view. All right, this is an instance where you get to view the libraries in application. And when we meet with app teams, they often say, hey, we already know what libraries we use. We've got other tools that scan for that in our pipeline. We look at a repo. But that's not what's actually being used by the application. You might find that there are 20 libraries listed in a particular repo, but you're actually only loading 10 of them into memory. So from a prioritization standpoint, what do you want to go fix? Vulnerabilities that you aren't using or the vulnerabilities that you are? So we instantly help them pay attention to stuff that's actually being used in that environment. And we are bubbling up the things that are aligned to their application they care about. Right? I care about my retail application and the inventory service. I want to get specific to that. Not just a repo, because a repo is not necessarily what's actually spinning up in your production environment. So let's say we dived into this common collections instance. Here we can see we've got 2 critical vulnerabilities and a medium vulnerability. We are going to give remediation guidance so that security teams could go back to the development team and say, hey, you need to upgrade this library. It's got some critical vulnerabilities, and you need to go from 3.2.1 to 3.2.2. And we see this running in the AD retail application. We see it in a particular service, the inventory service, so they can get really kind of very specific and help those app teams upgrade. In addition to that, we can dive into details like, are we seeing anyone exploit these vulnerabilities? That's going to also help change your prioritization. We're seeing attack activity in regards to this specific CVE happening within the secure application network. And so that's going to help someone make sure that they're prioritizing what matters most as well. Now, let's say they wanted to dive in to understand this vulnerability more. They can go ahead and click over to the vulnerability view. And we're going to give them more details about that vulnerability. Give an overview, give some details for it, explain how it works, and then also show where it sits across all of their environment, this particular vulnerability. So from a vulnerabilities perspective, here we are mixing together vulnerabilities that we see from the third-party libraries that the customers are using in their applications. We're also looking at some behavioral things. We see, for instance, that there's deserialization that's occurring, which could be an indication of a way in for someone to send malicious code that could be deserialized and executed. We're seeing clear text HTTP from these services. So we'll give them a purview of all of these items. We're going to score them with a severity and allow them to dive in deeper. And if we take a look at, from a severity perspective, we can see here, this is that commons collection again. We're going to bubble up that we've seen some exploit activity around it. We also see that there's a log4j vulnerability in here. You can go dive into this one. We can see the risk score for it. See, it's a 9.8. That's obviously pretty high. I want to go ahead and address this. And you have a couple of options, as I mentioned before. In the case of the log4j very first remote code execution vulnerability that existed, this is where you'd want to put a policy in place while you were waiting to go get that updated and push out to production. And you could leverage our policy engine to go and create some controls for how that application behaves. In the case of that attack, this is all we had to do to protect all of our Java applications in our environment. We simply created a policy rule that applies to all applications, all of our tiers. And the rule said, if a stack trace contains this vulnerable method from the JNDI manager class, the lookup method, we're going to go ahead and block a network connection that's going out from that vulnerable method. And at that point, once we click update, it gets pushed out, or downloaded, I should say, from all of our agents. And those agents then will stop that from being taken advantage of. And at that point, we can take our time to make sure that we are testing and validating that upgrade to the new log4j library so it doesn't introduce any instability into our environment. So once we've got policies in place, this is when we start looking at the attack side of things. We can see there's a number of attacks that we've seen come in here. We have SSRF, remote code execution, deserialization. And what you can see here is that some of them are being blocked and some are actually exploited. And I'm going to see if I can find a really interesting case with deserialization and remote code execution. So we're going to search on an attack type of deserialization. Well, not my lucky day for phishing. Okay, so let's jump into this remote code execution. So in this example, we've got an individual event that was received by the inventory service. It was a remote code execution. It was actually blocked. But even though we blocked it, we're capturing a ton of details that the security team is really going to want to know, as well as the folks on the app side of the house. One, what was the event trigger, right? Someone who's on the SecOps side has got a million things to worry about. They want to be able to filter down to what matters the most. So what do they actually do? Because I might not be able to deal with all of those attacks that are coming in. So we're going to bubble up exactly what we saw that attack try to do. In this case, they were just looking at the password file, right? In that case, there's salted hash, nothing to really stress about. They're doing some recon. It's obviously not good, but if I got that compared to someone else who's destroying data or stealing data, I might want to prioritize differently. We also get a purview to how they got into the application. What was the entry point? So we see the inbound request that came into us. We see from a network perspective where they came from and their actual client IP address. In the case of someone who's going through a proxy, load balancer, you're going to have an exported 4 header in there. We're going to extract that out and actually give you the external IP address for this person. And then we're leveraging the Talos threat feed to determine whether or not these were potentially a known bad actor that should be on a block list. So we'll identify suspicious actors from the Talos feed. And that's true whether it's an inbound connection or if it triggers an outbound connection, we'll also let you know whether or not that's a suspicious entity based on our Talos feed. And in this case, if we dive all the way down to the part that's going to matter most, because when the security team takes this to the app team, they're going to say, great, what do you want me to do about it? How do I go about fixing it? We're actually going to give them a stack trace. We're going to say, because this makes, if you're a developer, they're going to say, oh, cool. Now I know how they entered the app. I can see how they traversed through it, and I can see where it actually ended up hitting a method that resulted in this remote code execution. And if we can, if this is not a 0-day attack or it's not custom code, it's based on a known vulnerability like log4j, we have the ability to highlight the exact line of code that is vulnerable, that was taken advantage of, to make it even simpler for them to jump in to try fixing and putting mitigations in place. And lastly, observations. This is one where you only want this information when you want it. Meaning you're not going to come in here and look at these observations and take some kind of action based on it. It's going to be, you've got an incident you're investigating, you're in SecOps, incident response, you know that a breach occurred and you need to get quick visibility to what happened in the application. In most cases, a large enterprise cannot mandate an application logging standard. We have not seen that at any of our large customers. It's kind of the wild, wild west. If an application team is doing their job logging what they need to, great. But if they're not, you don't have any visibility. So incident response teams want to be able to see what was an application doing around a specific time. We capture that information for them, bubble it up, and give them the same level of detail. Right? So here we've got a file read that occurred. We also see some network activity. We're going to bubble all these events up. And from a SecOps perspective, they might use this to figure out how big a blast radius was this, right? Did they end up pivoting out from here to somewhere else? And we'll be able to show them all of these events, even if the applications weren't doing any type of logging at all. We'll have some resource utilization logs provided to them out of the box without any kind of config. And then last but not least, eyes on screen is a daunting task. And we've got the ability to define outbound connections for things like Splunk. So you could send this to your Splunk SIM, right? And you can make sure all of these events are getting to the people they need, included into your existing workflows, and take actions on it. And at that point, then what you've done is made sure the security team has the data they need. The app team is able to correlate information that matters to them, like what libraries are used where. That the security team, when they have a vulnerability, they can say, hey, it's in this particular service. Hey, here's how you should probably remediate this vulnerability. You should upgrade this particular library. If there's an attack and you need to go, the security team needs to go in and talk to the app team to fix it. They have a stack trace. This tool is trying to break down that barrier we talked about before, where security and app folk kind of constantly butting heads. And from here, we're hoping that the next time that you get a 0-day like log4j, that people are able to react a lot quicker than they were this time around, and hopefully save their holidays.
So Randy, I actually have a question about that, because this is one of the things that came up during that whole mess that because we know that if we can catch something, if we can see something happening, obviously we can write rules to block it. And I saw some of the craziest regex strings to block this that well, I've seen outside of Perl. But how does AppDynamics block something we don't know about? Because like the thing is, Log4j existed for years. Like this wasn't a vulnerability, it was just a quirk of the system until someone got creative and figured it out. What's the dwell time, I think is the right word. What's the dwell time between this being actively exploited and AppDynamics jumping in? And you mentioned that you were getting threat feeds from Talos. Is that like the trigger? As soon as Talos sees it, you guys can slam the front door on people and the back door too?
Yeah, so we have a couple of approaches here. So first one, we are able to see anytime remote code execution occurs, and we instantly bubble that up. And if you want to go ahead and block it across an application, it's a very simple policy to do that, right? You would just go ahead and create a policy for your front-end service, let's say, right? Or any service, and you can go ahead and block command execution. So that doesn't matter what the 0-day is. At that point, you would not be able to execute remote code in your application. And that's something that you could define without any type of effort or heavy lift. From a threat feed perspective, we're going to identify those risk signals or the signals that we're getting from our feeds, and be able to bubble that up instantaneously. And then obviously you can take action based on that. Like in the case of Log4j, with our blocking of remote code execution, that wouldn't have occurred in any of the applications, even if vulnerability wasn't known. But you want to be really targeted, right? There are going to be cases where maybe you want to allow remote code execution. You've got a unique case for it. So you want to have the flexibility to define a very precise type of policy that allows you to allow the application to keep operating as it is, but stop something bad from happening. And that's where we've got this example here. So you mentioned a WAF as an example. WAF, you'd put your policy in place. You have some kind of crazy regex. And there's no guarantee that you're capturing all variants of it. And it was just a whack-a-mole game with that regex. And there was plenty of instances where people actually were getting through the WAFs. So you need something else there that isn't going to block an entire request, but just the very specific action. So in this case, if someone has a legitimate request, we're going to allow that to come through. If that legitimate request happens to trigger a vulnerability, we'd be able to stop just that thing from being exploited and not the whole request and blocking the whole thing.
So in essence, what you're saying is that AppDynamics doesn't block the vector; it blocks the action. So, like how any security researcher out there will tell you, doesn't matter how they kick in the front door, how creatively they get, they always do the same things: lateral movement, reconnaissance, privilege escalation. You guys are blocking that back end so that it doesn't matter what it looks like. We know what they're trying to do, and we keep it from doing that.
That's exactly right. Yep. And the other piece that's important to understand in the case of a WAF, that's essential. Like, don't think Randy here is saying you don't need it. You need that out there at your perimeter for sure, because you want to try to filter out as much bad stuff as you can, because you don't want to put any additional load that's unnecessary on your application. But when it gets there, that means it's really bad. Someone's found all the loopholes. They've at your application. You need to make sure that you can protect it. You also need to be able to protect from lateral movement, east-west, insider threat. Insider threat makes up about 50% of all attacks. That's somebody that you've extended trust to in your environment. They're sitting in there. What happens when they want to go and try to take advantage of this Log4j vulnerability or any vulnerability? You need to have some protection that's sitting there with the application where your perimeter-based security won't be able to stop it from happening.